Finding x and y intercepts. Example 3. X minus 3 squared over 4 plus y minus 4 squared over 25 is equal to 1. This one is definitely more difficult than the last two examples, but we are still able to find our x and y intercepts. I again suggest that you pause the video and see if you can come up with the solutions to this on your own. Before I look at either one of these individually, the first thing that I'm going to do is I'm going to get rid of my fraction format. And I'm going to do that by doing my magic trick. I need to find my LCD between my denominators, so my least common denominator between 4, 25, and 1 is going to be 100. So I'm going to multiply both sides of my equation by 100. Or by 100 over 1. The right-hand side is very easy to see. 100 times 1 gives me 100. On the left, when I take 100 and divide it by 4, that gives me 25. So 25 times the x minus 3 squared. Plus. Now when I take my 100 times my second piece, I have 100 divided by 25. That reduces to give me 4, so 4 times y minus 4 squared. Now this is going to be much easier to deal with in finding my x and y intercepts. So let's start with our x intercept. And I find that by letting my y value be 0. So 25 times x minus 3 squared plus 4 times a 0 minus 4 squared is equal to 100. And I need to simplify this to figure out what my x value is. So this part here I can't do much with. Let me keep it as is for a while. 25 times x minus 3 squared. Here, I can get rid of my 0, which gives me negative 4 squared. And negative 4 squared gives me a positive 16. Simplify this here. 4 times 16 gives me a 64. I'm trying to isolate my x variable, so let's move the 64 to the other side. Gives me 25 times x minus 3 squared is equal to 36. Again, I'm trying to isolate my x variable, so I do that by dividing by 25 on both sides. Gives me x minus 3 squared is equal to 36 over 25. To get rid of my square, I force in a square root on both sides, which forces in a positive and a negative. So that leaves me with x minus 3 is equal to positive and negative. Simplify each, both the top and the bottom of this fraction. Square root of 36 gives me 6, and square root of 25 gives me 5. My last step here is to add 3 to both sides of this equation. And that leaves me with x is equal to 3 plus or minus 6 fifths. Since both of these are pretty or rational numbers, meaning whole numbers and fractions, we can actually go further. We have the version of 3 plus 6 fifths, creating a common denominator and adding those together. That gives me the answer of x equals 21 over 5. Or my x-intercept is 21 over 5, 0. I also have x equals 3 minus 6 fifths, again creating a common denominator and adding those together. Gives me the answer of x is equal to 9 fifths, or the ordered pair of 9 fifths and 0. So So I have two x-intercepts here, one at 21/5, 0, and one at 9/5, 0. Now I need to do this all over again, but this time we're finding my y-intercept. So again, I'm going to use this equation here, so I don't have to worry about my fraction. So to find my y-intercepts, you need to let your x-coordinate be 0. So I have 25 times 0 minus 3 squared plus 4 times y minus 4 squared equals 100. And now I need to solve for my y variable to figure out what my y-intercepts are. On the left, simplifying, getting rid of this 0, I have 25 times negative 3 squared, or 25 times 9, or 225. Carrying down the rest of my problem, I have 225 plus 4 times y minus 4 squared is equal to 100. To isolate my y variable, I need to get rid of everything else. So first let me subtract 225 from both sides. Gives me 4 times y minus 4 squared is equal to negative 125. I need to get rid of this 4 by dividing by 4 on both sides of my equation. Gives me y minus 4 squared equals negative 125 over 4. To get rid of my square, I need to square root both sides. And whenever you force in a square root, you also force in a plus or minus. On the left, my square and my square root cancels out, leaving me with y minus 4. On the right, I have plus or minus, square root each of those individually. Now, technically, I need to simplify the square root completely, but let me show you something that happens here. I have a square root of a negative number. And we have learned that square root of negative numbers are i's. So I'm going to have an I here times, okay, the rest of my square root. Now, really I should be simplifying the square root here, but I'm going to show you why I don't need to. If I'm trying to find intercepts, meaning if I'm trying to find points on my graph, and I come up with an I as a solution, that means I'm trying to come up with an imaginary point on my graph, which is impossible to do. If you ever come up with an imaginary number when you're trying to find intercepts or points on a graph, that just means that those points do not exist. So I do not need to simplify this any farther because these are pretend or imaginary or made-up points. So that tells me at this point there are no y-intercepts. And you do not need to solve that any farther. Now let me show you a visual of this last example that we've been working on. Our problem was all of this up here. This actually graphs into an oval shape, or what we call as an ellipse. And this is the version that we got here. And this is the graph of this oval or ellipse that goes with this equation. If we look back, we got the x-intercepts of 21 over 5 and 9/5, 0. If we figure out the decimal approximation of 21 over 5, that is approximately 4.2. So we should have an ordered pair at 4.20. Our other x-intercept that we got was 9/5. If we figure out what 9/5 is approximately, it's 1.8. So we should have an ordered pair at 1.80. And we do. We have those two ordered pairs. The first one at 4.20 is right here. Our second one of 1.80 is right here. Notice on our y-axis here, notice that blue oval or that blue ellipse never intercepts that y-axis. So that is why we came up with no y-intercepts, or that is why we came up with I, or imaginary numbers, or answers when we were looking for y-intercepts. So this is the visual to go with the last problem. Our two x-intercepts and no y-intercepts that go with it. If you would like visuals to go with our first example here, you could very easily solve these for y and plug them into your graphing calculator. Or if you'd like some more practice of graphing by plotting points, you could come up with your own table and plot points of those on your own. So this is the end to the video of finding your x and y intercepts.